So we're going to do hypothesis testing for proportions. So the hypothesis test for the z proportion, z test for a proportion P, okay? A statistical test for a population proportion. Now, the test statistic is P hat. P hat is equal to x divided by n, where x is the number of successes and n is how many total in sample, right? It's the sample proportion. This is the sample proportion. That's the test statistic. The standardized test statistic z is equal to p hat minus p over the square root of p times q divided by n. Now, if you've forgotten, if p is the probability of success, q is equal to the probability of failure, which is the complement of success, 1 minus p. All right? Now, this is true. What are the keys to the Ferrari here? N times P has got to be greater than or equal to 5. And N times Q has got to be greater than or equal to 5. If this is true, then the normal distribution can be approximated by the binomial distribution. Okay, the binomial distribution. So the mean of the proportion, sample proportion, is equal to the proportion, and the standard deviation of the sample proportions is equal to the standard deviation of P divided by, P times Q divided by N, square rooted. So that's our formula, and there's our test. Okay, so what we're going to do is we're going to work through an example using the proportion. So, researcher claims 51% of adults believe incorrectly that antibiotics are effective against viruses. So if you go out and get the corona, don't be taking no antibiotics thinking that's going to fix it. It's not going to do any good, okay? So they believe incorrectly that all they've got to do is take some antibiotics and then that'll kill the virus. Now, in a random sample of 2,202 adults, 1160 say that antibiotics are effective. Okay, so 1161 say that they're effective. At alpha equal to 0.10, is there enough evidence to reject the researcher's claim? All right, so first thing I want to do is I want to write down my ho and my ha. So who's the ho, who's the ha? First number I see, 51%. Now, you might be asking yourself, how do I know to use P and not mu? Okay? Mu is used when I see the word mean. P is used if I see like a percentage. My goodness, that's going to be a proportion, right? It's a percentage. P percentage, P proportion, okay? So that's how I know I'm using a proportion here. So 51% claim incorrectly that antibiotics are effective. Now, This is the claim. P equals 0.51, 51%. That's my claim. So 51% of people believe incorrectly that antibiotics will actually work against a virus. So basically, it's like people don't know, so they guess. 50-50 shot, right? Yeah, sure. Sounds like antibiotics would work. Or yeah, no, I don't know. Probably not, right? So the opposite of P equal to 0.51 is P not equal to 0.51. That's the alternative hypothesis. Now, to use the test, we have to make sure that NP is greater than or equal to 5. Now, what is NP? N is the total number of people that they sampled, 2,202. Now, P here, P, okay, so N was 2,202. The P, the proportion, this is P 0.51, okay? When I multiply this out, I get a number pretty big. So somewhere close to 1123. My goodness, that's definitely big enough. What about NQ? NQ is 22002, and then Q will be 1 minus P, so that's Q is 1 minus P, so that's 1 minus 0.51, which is 0.49. Multiply 0.49. Guess what? That number is definitely bigger than 5 also. It's like over 1,000. So we're definitely good to go. So I'm going to write over here CLT. Okay, so that's what you're going to put on your scratch work when you're taking this test. All right, CLT. Now, what type of test is it? How do I determine the type of test? I look at the HA. When I look at the HA, I see not equal to, so that's a two-tailed test. A two-tailed test, okay? So let's run through our test. Z equals P hat minus P over square root PQ over N. Now, I've got all the players except for, well, what the heck is P hat, right? I know that P is 0.51. I know that Q is 0.49 and N is 2202, but I don't have a P hat. How do I get P hat? P hat is the sample proportion, right? What did our sample say? Our sample said I went out and asked 2,202 people, and 1161 said, yeah, antibiotics do work against viruses. So P hat is 1161, the number of successes, over 2202. Now it just turns out here that number of successes, okay, these are all the dumb people, right? So just because you hear it as considered as a success doesn't mean it has a positive spin on it. It's just a positive connotation with the word success. All right, these are the dumb people. So 0.527, or the misinformed, to be more politically correct. All right, so 0.527 minus the 0.51 divided by the square root of that nasty thing. When I type that in my calculator, my suggestion is do this first, and then do second answer and then square root that, and then figure out this numerator and then divide the two. Okay, that might help you because it's kind of a lot to type into your calculator all at once. So maybe I should show you what I mean. All right, so it's kind of complicated. So like just do like parentheses 0.51, close parentheses, times what? Parentheses 0.49, close parentheses, divided by, what am I dividing by? Well, I'm dividing by 2,202, okay? So that number right there, I want to take the square root. So second square, second answer, the little negative sign, and then hit enter. Okay, so that's what goes in the denominator. So in the numerator, I had parentheses 0.527 minus 0.51, close parentheses, divide by second answer, enter. And that's where the 1.595 comes into play, but I rounded 2 decimals, so 5 or more, raise the score, 4 or less, let it rest. So 1.60. 1.60, right? Now we got to see, does this number fall in the rejection region? Okay. Alpha here for this particular problem was 0.10. So I'll look at my situation that's going on here. If I have a 10% alpha and it's a two-tailed test, that means 5%'s over here and 5%'s over here. So I got to figure out what this critical value is. So once I figure out the critical value, if the z that I found, okay, let me change this color. Okay, let me change this to black. All right. If the z that I found is in here, in the middle here, then I don't have to reject. I fail to reject. That's the non-rejection region. But if I find a z that's out here or well over here, then my goodness, this must not have come from that hoe right there. Therefore, I would reject the hoe because it's probably lying. Okay? So we got to see where the critical values are. To do this, I got to look up 0.0500. Remember, this is that key one that I said pops up 100 times or 89 times or whatever it was, right? So this is going to be negative 1.645 when you go look it up in your z-chart, all right? And then over here, if this is the negative 1.645, this is the positive 1.645, okay? So where does our statistic z equal 1.60 fall, right? It actually falls right here, okay? Z equal 1.60. Now, is this the rejection region or the non-rejection region? In here, between these two values, that's the non-rejection region. So we fail to reject the hoe. Why do we fail to reject the hoe? The reasoning why we fail to reject the hoe is because the hoe is between 1.645 and negative 1.645, okay? The hoe that we found is between those two values. It's right there. It's between this value and this value. So the reasoning for why, you get 1 point for telling me why and 1 point for telling me fail to reject. Okay? So how do I write this? All right? I say there is not. Why do I say there is not? Because it's fail to reject. Fail to reject tells me there is not enough information. So there's not enough evidence at alpha equal to 0.10 to reject. Why do I use reject here? Reject is used because the claim is the hoe. The only thing I can do with the hoe is reject the hoe. Okay? So reject the claim that what? 51% of adults believe incorrectly that antibiotics are effective against viruses. Okay? So here we have used the rejection region for making a decision to reject or fail to reject. We use the rejection region. This middle region here fell to reject the non-rejection region, right? So we could have used p-values here, okay? We could have used p-values. To use the p-value here, the p-value says what? If the p is low, the null must go, right? Reject the hoe. If the p is big compared to alpha, it's bigger than alpha, I fail to reject the hoe, the null hypothesis. Okay, so those are my two options. Now, for this particular one, in order to find the p-value, you've got to use your calculator. Okay, you need to use your calculator. Now, your calculator here can help you get the solution, right? Stat, test, and then hit the one prop z-test. Okay, so hit the stat button, then test, then one prop z-test. And you're going to see p0, you're going to see x, you're going to see n. Okay, so what do I put? For p0, I'm going to put 0.51. For x, I'm going to put 1161. For n, I'm going to put 2202. And I'm going to say not equal to p naught, because remember the test, the hoe was p equal 0.51, and the ha, that's the type of test, was a two-tailed test. So this tells me that it's a two-tailed test. And then hit the calculate button. Okay, hit the calculate button. And what's going to happen is it's going to spit out a p-value equal to 0.1054. A p-value equal to 0.1054. Now, this thing right here, this is bigger than alpha of 10%, okay? Therefore, we come to the same conclusion that we did up here, all right? We fail to reject the big P, okay? If the P is big, I fail to reject. That's what's going on there. Hopefully that will help you out when you are working through your problems in 7.4, okay? Good luck.